right?
So
So
shall I just introduce you? Okay, so now we have two papers on visualizing text and data, and the first one is from Taekyeom Lee, apologies for pronunciation, and it is Tangible Type and Code. Thank you.
So actually last night we, with Yeohyun, we get together and recorded the video. So I can, wait a second, I want to make sure I record the sound. Okay, there we go. Can you see my screen here, the video?
Yeah, but we need a full screen.
Okay.
We can see the desktop.
Oh, I see, I'm sorry. Okay, yes.
Yes.
There we go. Hello, my name is Taekyeom, and I'm an assistant professor of graphic design at Iowa State University. I'm with my collaborator, Yeohyun Ahn.
Hello, my name is Yeohyun Ahn. I'm an assistant professor of graphic design at the University of Wisconsin-Madison.
Today, we will talk about our collaborative project, TangibleTYPE CODE. Our paper starts with this. Language is a way of human communication. Visual languages is a system of communication using visual elements. It is a visual representation of the written language. The TangibleTYPE CODE enhances direct experiences of typography from written and visual communication to tangible communication by computation and digital fabrication. TangibleTYPE CODE is a collaboration between Type Code series and TangibleTYPE. Type Code series by Yeohyun Ahn explores the expressive aesthetic of computational typography. TangibleTYPE by Taekyeom Lee extends typography to perceptible typography with physical touch by using digital fabrication. Historically, type design or typography considered as designing letters on flat and static surfaces. However, with the development of digital technologies, it naturally extends its property to physical and spatial realms. We need a bit of time travel. Letters are materialized sign of spoken language, although language was developed much earlier than written language. Writing did not emerge until clay tablets were used for record keeping around 3100 BC. While pictorial signs were also used in the earlier form of writing. Earlier form of writings, letters are made out of various abstract geometric shapes, including dots, lines, squares, and wedge. Typography and printing has been done by hand for a long time. The computation was embedded into the type design process as a rule-based type design system in 1954 by Adrian Frutiger's font, Universe. Frutiger's approach to design of the universe was radically different from other fonts. He focused on creating system of interrelated wedge.
In the early 2000s, pioneering works of computational type design began at MIT's Media Lab. Professor John Midas, graduate student Peter Zhou investigated and showcases expressive, dimensional, and interactive letter forms and typography by using computation through his thesis, Computational Models for Expressive Dimensional Typography. We will talk about our individual projects, Type CODE. Type CODE explores legible, readable, and expressive type design by using computation. It is initiated by Yeohyun Ahn as her MFA thesis at Maryland Institute College of Art. Type plus code show the aesthetic of code-driven typography by using processing. Processing is a basic programming language for artists and designers, initiated by Ben Fry and Casey Reese. It experimented with traditional and culturally oriented calligraphy to reinterpret into modern and expressive typography by using computation. It used letter forms to explore innovative typographic forms by using mathematical expression. Type plus code 2, the second version, extends the letter forms to words, phrases, and sentences. It conveys diversified visual messages inspired by nature, addressing environmental issues such as green design. The third version, Type plus code 3, shows the possibilities of extension of aesthetic of code-driven typography from cyberspace to physical space by using design fabrication. It was the first collaborative work with Taekyeom Lee. The type was originally designed with processing. The letter A was 3D printed with porcelain. The fourth version, Type plus code 4, is a computational type design system to explore expressive letter forms. It shows how a custom illustration can be embedded into a selective typeface to explore legible and expressive typeface designs in a generative system.
Tangible type translate the digital type into tangible and dimensional typography form using 3D printing to enable the new typographic experience. Designers can use a variety of printing techniques to produce visual materials to solve visual problems. Digital fabrication can change the notion of printed text and how we experience materialized type. Three-dimensional printing in particular has become more refined, common, and accessible. These new technologies have introduced new tools for pushing the boundaries of typography in both in terms of concept and medium. The first phase of this research project was building DIY 3D printers to work with various unconventional and conventional materials in 3D printing, such as clay. I became a designer and a toolmaker. The letter form looks aggressive, and it is actually aggressive. It's pretty sharp. I know that it poked my fingers several times. The letter form was built from numbers of corn as building blocks. It's similar to the modular construction, but the size of corn varies depending on the parameter. The 3D printed type embosser is inspired from the cylinder seal, an ancient historic artifact, leaves impression in wet clay. It is digitally designed and 3D printed. It provides not only visual experience, but also engaging physical experiences. Not like today's printing technology, the process involves rich, tangible experience. The ring were 3D printed with a flexible material called thermoplastic polyurethane, called TPU, which is safe to wear and provide interesting tactile experience. Tangible type plus code. Visual and touch are closely linked together, although touch is fundamentally non-visual perception. When we look at things, we can imagine how they feel if we touch them. When we finally touch something, we feel more connected and enhance our memory with the object. Tangible type plus code suggests another linguistic experience beyond the spoken, written, and visual languages, as it extends typography to the physical realm with touch by using computational design and digital fabrication. Times New Roman was used as a base typeface as it's one of the most influential typeface in history. Also, it's a standard typeface on personal computers. The preliminary design was tested using processing. The letter form is made out of circles. Uh, uh, as, as it's one of the most simple geometric shapes, also it's used in earlier form of writing. It's implemented by using geometric library in processing by Richard Maxer. Based on the preliminary designs, the three-dimensional letter form was designed using CAD software called Rhino and its plugin called Grasshopper. Grasshopper is one of the most popular parametric modeling tools and it's commonly used by many areas, such as architecture, design, and other areas of art. Parametric modeling enables rapid transformation and makes repetitive work easier. The size, position, and density of the circle was drawn depending on the parameters. Spheres was used to construct characters instead of circles, as the design should be a solid three-dimensional object. The design and fabrication process is closely related, as it's crucial to materialize the idea with physical substance. It's a particularly important step because we aim for not only visualizing but materializing the written language. For example, as the letter has to be a single piece, the dot has to be touched one another. If not, the letter would be falling apart. Based on the experiments from TangibleTYPE, we decided to 3D print letters with polyitic acid, which is called PLA. PLA is one of the most popular corn-based bioplastic in 3D printing. It's easy to print, affordable, and biodegradable. The material is also suitable for this project as it's light and safe to play for children. Various different colors are available in the market, but filament gives the color gradient was chosen to attract the users. Touch can enhance and reinforce the user's experience with the text, and the idea has been done with traditional printing methods. We aim to bring it to the next stage with new digital technologies such as computation and 3D printing. It makes the type available for the public to engage it to be touchable, playable, and discoverable for new linguistic learning experiences. The research is extendable to develop educational environments and programs for schools and children. It will supply engaged learning opportunity for children who start learning language by using one of the human senses, touch. It practices a multisensory approach to learn type beyond verbal, written, and visual languages. The computational design enables us to create generative, expressive type design systems that are transformative to tangible types. The project suggests the possibility to provide a new linguistic experience, which uses type as expressive, dimensional, textual, and touchable form. This is still the first stage of the investigation, and more investigation should be followed. Over the summer, we made a little progress. However, we cannot test it with users because of COVID. I tested it with different materials. That the pink S was 3D printed with flexible filament, TPU, which was used to make wearable rings. Letters printed with PLA plastic could be broken when there are weak points. A flexible one is durable and unbreakable by hand. The E was printed with color-changing material. It's 3D printed with PLA filament, which is the color changing pigment was infused. It changed the color from purple to pink when participants hold a piece with warm hands or ambient temperature is higher than 31 Celsius or 88 Fahrenheit. We hope this presentation could be inspirational. Please contact us if you have any questions. Thank you very much.
Thank you. Are there any questions? I don't see any on chat yet, but please add your questions if you have any. Some of your earlier projects, the examples you showed us were much more abstract in form. So how important is legibility in some of those earlier ones? How far would you go, in turning it from something that doesn't really look like the type anymore?
Good question. Yeah. Yeohyun, you want to go first?
Oh yeah, because I'm a graphic design professor. That means that when we are using computation, we have to be aware where we have to go, where we can go, where we have to go. So when I started the computation, that it should be a medium for typography. So typography has a certain principle and rule that we should follow as a graphic design, as a graphic designer. So I follow the principle that in typography, it should be legible and readable for the audience to read. And also it should be expressive to deliver visual messages. That is my 3 principles that when I'm working with the computation to create typography for primary graphic design.
Yeah, I agree, because the image is basically pictorial sign and type is alphabetical sign, and we all using just sign to communicate something, to embed some meaning, or so. I think that type is a vessel to hold it, and in that sense, using the ceramic for, like in the history, using the ceramic for typography totally makes sense, because it's the vessel to hold the meaning, and we can convey it and deliver it to different audiences. And definitely that's before we invent the printing, but that's how we make it copyable so we can distribute it.
Okay. So no more questions at the moment, but if you have any, please put them up on chat and we can look at them later.
I forgot to include it inside. Actually, over the summer, I made the soap, the text using the bubbles. So bubble, soap, and then we can wash hands. And I'm gonna just put a link here, and I have some video me making the soap there too. So I think the design itself can be applied to different medium once we can materialize it. So thank you very much, and feel free to email us if you have any questions after this. Thank you.
Go on to our next